Okay, so let's go through the radiation pressure of the quantum physics. So if this beam of light incident normally on a metal surface as illustrated in the figure. So of course, we have the beam of light. So we are given a few parameters, right? So first thing will be the area, cross-sectional area, meaning this part. So of course, another is your power. So remember power, right, is energy divided by time. So of course, the next thing will be the wavelength is given to be 570 nanometer. So the light energy is absorbed by the metal and no light is reflected. So okay, the very first part they say show that the photon, right, a photon of this light has an energy of 3.5 times 10 negative 19 joules. Okay, so one only. So of course, you simply just use E equal to hc over lambda. Then you sub in, right? So you should get the 3.5 times 10 negative 19 joules. So that's the very first part, quite simple. Okay, for the part 2, the part 2 is the more difficult one already. Okay, so calculate for the time period of 1 second, right? How many number of photons, right, are incident on the surface? Okay, so first, we know that the power of the light is about 2.7 times 10 negative 3 watts. So I want to determine what is the total energy of the light EM radiation, right, in 1 second. So you simply just use P equal to energy divided by time. So meaning that the power is given as 2.7 times 10 negative 3. Then the time, right, is 1 second. So meaning that in 1 second, right, you will have a total energy of 2.7 times 10 negative 3 joules. Okay, so with this, we know that one photon, right, contribute to an energy of only 3.5 times 10 negative 19. So you just divide. So when you do the division, you will get a total number of photons to be 7.71 multiplied by 10 to the power of 15. So that is the number of photons in 1 second. Okay, so this one also quite simple. Okay, for the part 2, a bit more challenging, I would say. The change in momentum of the photon. So of course, the change in momentum means the final momentum minus initial momentum. How do I actually do this question? Okay, the initial momentum we know how to calculate. If you remember your de Broglie wavelength, P equal to h over lambda, you are able to determine what is the initial momentum of one photon. So you simply just use a Planck constant, right? 6.63 times 10 negative 34 divided by the wavelength of the de Broglie wavelength of the photon. So one photon, the initial momentum is 1.16 times 10 negative 27. That's only for one photon. Okay, before I talk about the total number of photons, I want to talk about the final momentum. If you look at the final momentum, if I go back to here, right, so there's one very critical statement they say. No light is reflected. Means that all the light is being absorbed, and meaning that this statement means that the final momentum is equal to 0. Because all the light is being absorbed by the metal surface. Okay, so the final momentum is 0, meaning that, for example, right, delta P equal to final momentum minus initial momentum, you simply just get the delta P, right, to be the 0 minus away your 1.16, right, multiplied by 10 negative 27 kg meter per second. So you just get the modulus of it, meaning you just get the magnitude, right? So this will give you a total momentum, change in momentum to be 1.16 times 10 negative 27. So that's for one momentum, but apparently we want all the photons, right? So we simply just multiply by 7.71 times 10 15. So that's the total number of photons in 1 second. So the total change in momentum is given to be 8.97 times 10 negative 12. So that is for the second part. Okay, the last part is part C, right? We are asked to calculate the pressure that the light actually exert on the metal surface. How do I actually do this? Okay, for the pressure wise, we need to go back to the fundamental formula, meaning the formula that we learned in our O level. P equal to force over area. So okay, we need force, we need area. We need these two things, then after that we can determine the pressure. Okay, the area is given to us already. So area is given, if you look at the question, right, the area is given to be 1.3 times 10 negative 5. The thing that's not given to us is the force. What is the force that the light actually exert on our metal plate, right? Okay, so this is where you need to go back to the force equal to delta P divided by delta T. Now remember your Newton's second law in terms of A level definition, right? Okay, so force is equal to delta P divided by delta T. So delta T is the 1 second time frame. Delta P is the change in momentum, meaning the total change momentum from all the photons. Okay, so you use the second part answer. 8.97 times 10 negative 12, right? You divide by 1 second. So in 1 second time frame, the photons actually exert a force of about 8.97 times 10 negative 12 Newton. So that is the total force in 1 second. Then you can simply just divide already. So for example, right, for the second part, the pressure is equal to 8.97 times 10 negative 12. You divide by the area, 1.3 times 10 negative 5. So it should give you a pressure of about 6.9 times 10 negative 7 Pascal. So that is how we do this question.